Hi, my name is Efraim Orosco, here to discuss special purpose diodes, starting with the Zener diode. It's a type of diode that permits current to flow in the forward direction like a normal diode, but also in the reverse direction if the voltage is larger than the rated breakdown voltage, or the Zener voltage. The breakdown voltage of a Zener diode is set by carefully controlling the doping level, allowing electrons to tunnel from the valence band of the p-type material to the conduction band of the n-type material. The diode symbol for the Zener is. Another special purpose diode is the photodiode. The photodiode, unlike LEDs, receive light rather than produce light. The photodiode varies its current in response to the amount of light that strikes it. When the device is connected in reverse bias, no current flows unless light strikes the exposed junction through a tiny window. This produces reverse current that increases proportional to light intensity. This is a symbol for the photodiode. The next special purpose diode is the Schottky barrier diode, or the hot barrier diode. Schottky diodes are constructed of a metal to N junction rather than a PN semiconductor junction. Schottky diodes are characterized by fast switching times, low forward voltage drops, typically 0.25 to 0.4 volts for a metal silicon junction, and low junction capacitance. The Schottky barrier diodes are widely used in the electronics industry. Particularly, they are used in areas including RF mixer and detector diodes, solar cell applications, clamp diodes, especially when used in LSTTL, power rectifiers, and lastly, power OR circuits. The diode symbol for the Schottky is. The next special purpose diode is the varactor diode. The varactor diode is a type of diode which has a variable capacitance. That is a function of the voltage impressed on its terminals. Varactors are principally used as a voltage-controlled capacitor rather than as rectifiers. They are commonly used in parametric amplifiers, oscillators, and voltage-controlled oscillators as a part of phase lock loops and frequency synthesizers. The diode symbol for the varactor is. Coming up next is my friend Juvenile Cabiles to introduce more special purpose diodes.
Hi guys, good morning. My name is Juvenile Cabiles, and today I'm going to discuss three special purpose diodes, which are LED diode, the 7-segment diode, and laser diode.
Let's start with the LED diode. LED means light emitting diode, is a 2-LED semiconductor light source. It is a PN junction diode that emits light when activated. When a suitable voltage is applied to the LEDs, electrons are able to recombine with electron holes within the device, releasing energy in the form of photons. This effect is called electroluminescence, and the color of the light corresponding to the energy of the photon is determined by the energy band gap of the semiconductor. LED are typically small, less than 1 mm, and integrated optical components may be used to shape the radiation pattern. Next is the 7-segment diode. A 7-segment diode or a 7-segment display may use liquid crystal display or LCD, arrays of light emitting diodes, and other light generating or controlling techniques such as cathode gas discharge, vacuum fluorescent, and others. 7-segment diode are widely used in digital clocks, electronic meters, basic calculators, and other electronic devices that display numerical information. Last diode is the laser diode. This is an example of a laser diode. A laser diode, are also known as injection laser diode or ILD, is a semiconductor device similar to a light emitting diode in which the laser beam is created at the diode's junction. Laser diodes are the most common type of lasers produced with a wide range of uses. That includes fiber optic communications, barcode readers, laser printing, and many more. A laser diode is electrically a pin diode. And that's it. Next is Raeñel Calindas. He will discuss gun diode, tunnel diode, and pin diode. Thank you.
Raeñel Calindas, and I'm going to discuss about the gun, pin, tunnel, and constant current diodes.
The first diode that I'm going to discuss is a gun diode. A gun diode is also known as a transferred electron device, or TED. It is a form of diode in high-frequency electronics. It is based on the gun effect that was discovered in 1962 by physicist J.B. Gunn. Its largest use is in the electronic oscillators to generate microwaves. In applications such as radar speed guns, microwave relay data link transmitters, and automatic door openers. It consists only of N-doped semiconductor material, whereas most diodes consist of both P and N-doped regions. In the gun diode, 3 regions exist. 2 of them are heavily N-doped on each terminal, with a thin layer of lightly doped material in between. Here is the symbol of a gun diode and its characteristic curve. The second diode is a pin diode. A pin diode is a semiconductor device consisting of 2 narrow but highly doped semiconductor regions separated by a thicker, lightly doped material called the intrinsic region. Pin diodes are utilized mostly in microwave frequency applications. Its variable forward series resistance characteristic is used for attenuation, modulation, and switching. In reverse bias, it exhibits a nearly constant capacitance. This is the pin diode symbol and its characteristic curve. The next diode is the tunnel diode. The tunnel diode is also known as a ECE diode. It is a type of semiconductor that is capable of very fast operation well into the microwave frequency region, made possible by the use of the quantum mechanical effect called tunneling. It was invented in August 1957 by Leo Esaki, Yuriko Kurose, and Takashi Suzuki. Tunnel diodes exploit a strange quantum phenomenon called resonant tunneling to provide interesting forward bias characteristics. When a small forward bias voltage is applied across a tunnel diode, it begins to conduct a current. This is the schematic symbol for a tunnel diode and its characteristic curve. The fourth and last diode is the constant current diode. The constant current diode is an electronic device that limits the current to a maximum specified value for the device. It is known as the current limiting diode and the current regulating diode. This device exhibits very high impedances. Here is an example of a constant current application and its characteristic curve. One interesting application for a constant current diode is to automatically limit current through an LED or laser diode over a wide range of power supply voltages.